Hey guys, welcome back to another online lesson. This one begins Unit 8, and I'm going to get started with function tables. Here I have an image of a machine where you put something in one end, something happens in the middle to get an output or something different at the other end. What we're going to do today is going to be very similar to those input-output boxes you may have done in grades past. We're just going to call them function tables and function rules today. So here we have, this is the main part of the machine. This is what I'm going to call my function rule. This is where all the changes occur. Up here, this is what I'm going to call my input. I'm also going to give it another name called the independent variable. Get it? Input, independent variable. They both begin with IN. That's just a little trick to remember it. I'm also going to give it a third name. I'm going to call it X. So our input goes in here, hits our function rule, and then at the other end we have our output. The second name I'm going to give it is the dependent variable. And the third name I'm going to give it is Y. So let me walk you through an example. So here I have my function rule, and I'm going to call it X plus 2. Okay. X plus 2 is what's going to happen when my input hits the rule. And let's say my independent variable is 5. So 5 goes through the machine, hits the function rule. And instead of X, what I'm going to do is I'm going to take whatever X is, which is 5, plus 2. 5 plus 2 happens, which of course we know 5 plus 2 is 7. So therefore my dependent variable, or my output, is 7. So that's how these work. Probably very similar to those input-output tables you had. We're just going to kick it up a notch today. Here I have a typical function table. And if I could erase it, you'd see it a little bit better. Okay. So instead of it being this machine graphic that I showed before, we can represent the same thing just through a table. I have inputs. I have my function rule. And finally I have my output. Notice I put X and Y. Inputs are given for us. Our function rule is given. My function rule is X plus 7. We don't know the outputs. It's our job to figure out what the outputs are. So in this case, if my X is 10, then it would say 10 plus 7. And notice what I did there? Instead of copying X plus 7, I just substituted whatever my input is, plus 7, to get my output. 10 plus 7 is 17. My X, or my input here, is 12. 12 plus 7. 12 plus 7, 19. My input here is 14. 14 plus 7. 14 plus 7, 21. And there we have a complete function table. My X's, my Y's, we could graph them, and in class we are going to, but for right now we just want to complete this function table and we're good to go. But I mentioned we were going to kick it up a notch, and we're going to do it with this one here. We can also go backwards. My inputs, we don't know. My function rule, we do. 2x minus 1. My output, or my y, 1, 3, and 5. A little bit more challenging, but nothing we can't handle. So here I have 2x minus 1. I can't substitute for x because I don't have anything to substitute. But I do have what my output is. So therefore, we know that the output is going to equal 1. 2x minus 1 equals 1. Does this look like something we could solve? Yeah, this is what we did in the last unit. So what our job is, we're going to have to isolate what that x is to say x equals something, and then that'll tell us what the input is. So let's start. First, I want to start at the side with the variable, which is here. Oops, didn't mean to erase that too. Boom. So here we have 2x minus 1, and we need to get that x by itself. But first, let's get rid of this minus 1, because there's no variable attached to it. So let's get all the numbers to this side. To get rid of that minus 1, what we have to do is add 1, plus 1, plus 1. Remember, if we do it to one side of the equal sign, we have to do it to the other side of the equal sign. Minus 1 plus 1, those two will cancel. 1 plus 1 is 2. So we're left with 2x equals 2. Because it's 2 times x, to get rid of that 2, what we have to do is divide by 2 to both sides. Those will cancel, leaving x by itself equals 2 divided by 2 is 1. X equals 1. Complete. Now do we know what x equals? Yes, we do, because we just solved it. X equals 1. So my input is going to be 1. My output is going to be 1. There is a way to check. Let's just substitute in my x, and let's see if we get the correct output. So 1. So 2 times 1 minus 1. Order of operations, we do multiplication first. 2 times 1 is 2 minus 1. Does 2 minus 1 equal 1? It does. So we're good to go. Now, let's look down here. Same thing. We don't know what our input is, but we do know the output is a 3. So let's take our function rule, which is, I'll use pink, 2x minus 1, that equals 3. Now how do I know it equals 3? Again, I'm just looking to what the output is. 2x minus 1. Got to get rid of that minus 1 first. To do that, add 1 to both sides. Those will cancel. So we're left with 2x equals 3 plus 1 is 4. To get rid of that 2 times x, we have to divide by 2 to both sides. Those will cancel, leaving x equals 4 divided by 2 is 2. X equals 2. Therefore, my input is 2. And again, you could double check. 2, just substitute it in for x. 2 times 2 is 4, minus 1 is 3, and that is what my output is. One more to go down here. This time my output is 5. So 2x minus 1 equals 5. Perfect. Here, gotta isolate the numbers, gotta isolate the variables. So, what we're going to do is I'm going to add 1 to both sides. So we're left with 2x equals 5 plus 1 is 6. And wow, it is kind of weird writing way down here, but sorry, I gotta get kind of low. 2x equals 6. Divide both sides by 2. We are left with x equals 6 divided by 2 is 3. And my input, or my x, is 3. Again, let's double check our work. 3 times 2 is 6, minus 1 is 5, and my output is 5. Good to go. We can also do everybody's favorite, word problems. So while I erase the board, this word problem, if you can't read it on the screen, I put it on your paper, so you should be able to read it just fine. We have word problems, and we have a completely empty function table. Nothing we can't handle, though. Here we go. Brianna bikes 12 miles per hour. The function rule that represents this situation is 12x. Ooh, that's my function rule. Key important information there. Where x is the number of hours. Okay. Make a table to find out how many miles she has biked in 1, 3, and 4 hours. Okay. So we also know that x is the number of hours. So that's important. So let's go ahead and start piecing together our table. So here we have our input, our rule, and our output. That's standard. That's in almost every function table you'll see. We have their input, we have the rule, and we have the output. I'm going to also label them x and y, just so I can remember. And here we said our function rule is 12 times x. So our rule is 12 times x, where x is the number of hours. So here is our input, and x being the number of hours, so we're going to put the number of hours here. Make a table to find out how many miles she's biked in 1, 3, and 4 hours. Okay, easy enough. 1, 3, and 4. And our output is going to be how many miles. So it'll be miles. Let's do it. So if she bikes for 1 hour, it's going to be 12 times 1. 12 times 1 is 12. If she bikes for 3 hours, we're just going to substitute our 3 for our x. So it'll be 12 times 3. And 12 times 3 is 36. So the way this reads that if she bikes for 3 hours, she will ride for 36 miles. But what if she bikes for 4 hours? Well, it's just 12 times 4. And 12 times 4 is 48. So if she bikes for 4 hours, she's going to ride for 48 miles. There we have our introduction to function tables. I gave you a problem to solve at the bottom of your worksheet. Try your best. Any questions, jot them down. We'll talk about it in class. Have a good day.
Hulk Hogan says, "I stole your pencil." Ha 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 ha.